Hello friends, so we are going to continue our doubly linked list, and in our previous videos we have made our code of doubly linked list, and we made these methods called prepend, append, add before, add after, traverse, forward and backward. So now we are going to make some more methods to complete our data structure code. So let's quickly make the remove method. This method is going to be a long one, and it's going to take data as a parameter or an argument. Sorry. Now there are at least 5 or 6 cases that we have to check for, and the first case is when there is no node. So if self dot size equals to 0 and not self dot head and not self dot tail should without for head and tail node. The code should work without checking for head and tail nodes. Okay. Yes. So now we have to just print no data to remove. We have included this condition when there is no data in our linked list. The program should display this line of code. Okay. Elif self dot size is equals to 1. It means when the list contains one node, so self dot head is going towards anon, self dot tail will point towards anon again, and self dot size is incremented to by 1. Okay. Elif, we have to write the comment when the list contains more than one node. Elif self dot size is greater than 1. Now we have more than one nodes. Alright, so current node should be self dot head, because we are starting to traverse from the head node. Now we can create this previous node variable and it's set to none in the start, while current node, it means while the current node is not none. So if current node dot data matches the required data, and let's use the pass statement, else. First we can cover the else section. Previous node will be the current node, and current node will be updated to current node dot next. So data is not. So if the data is not matched in line 112, we are just updating previous node and current node variables so that we are traversing in the forward direction in our list. Okay, so let's cover up the remaining conditions that we have to check. Now, case 1 here will be removing the head node. Okay, so we are now going to remove the head node. So to remove the head node, we have to create a new variable next node which will point towards, or which will be a reference towards the next node to the current node. Okay, so as you can see, next node variable contains the reference of the next node to our current node, right? I hope I am clear to you all. So now we have to make sure that the current node dot prev is set to, oh sorry, not the current node, next node dot prev is set to a none, and current node dot next is again set to a none. We have to delete the current node finally, and self dot head will now be our next node. So let's see what we have done here. Next node is our new variable which is storing the reference to the next node to our target node. Okay, the target node is to be removed or deleted, right? So we have made this next node dot previous equals to none because the head always points toward a none. Okay, so in our singly linked list or our doubly list, the head or tail node always point towards a none, right? Now the current node dot next is set to none, and we have deleted the current node, right? Now we have to check for another condition, and it's going to be removing the tail node, right? So now we are going to remove the tail node. So if elif not, oh, I think I haven't included this condition. Sorry, my bad. If not previous node, and oh, I'm sorry, I have to write this line of code below the comment line. This, and we have to indent these lines. Okay, now it's fine. Elif not current node dot next. Okay. It means when the next node to the current node is a none, it means we are sure that it's our tail node, right? So what we have to do here is we are creating a, oh, we have the previous node, right? So previous node dot next should point towards a null, as the previous node is going to be a new tail node. So a tail node must always point towards a null. And current node dot prev will be a null again, and we have to delete the current node, and self dot tail will now point towards our previous node. Okay, and finally removing any random node but not the head and the tail nodes. Else section. Now we have to create next node again, and next node is going to be current node dot next, and so what we have to do here is we have to interconnect the next node and the previous node, and we have to delete the current node and all of its references, right? So current node dot prev equals to none, current node dot next should be a none again, and we have to finally delete the current node, and now previous node dot next should point towards our next node, and next node's previous variable should point towards our previous node, right? So we have finally interconnected the previous node and the next node, right? And so I think we are done with this, and self dot size will be reduced to -1, as we are removing the node here and we are using the return statement again, so we don't end up in an infinite loop. So infinite loop. I think this code should work fine as far as I know. Next node, current node dot next, right? Okay, so let's just check it. So we should just check our remove methods condition at once. So we are going to remove -3, 0 and 4. Okay, so -3, 0 and 4 should be removed. So minus mylist dot remove -3, mylist dot remove 0, and mylist dot remove 4. Okay, I think we have successfully removed -3, 0 and 4. -3, 0 and 4, and the number of nodes is 1, 2, 3, 4, 5, 6, 7. Correct. So the number of nodes is 7. So we have finally created our doubly linked list program, and let's add one more function to this method, right? So it's going to be define find. Let's create this method. This method is going to find our data. So current node is going to be self.head, and while current node, I should write it again, while the current node is not a null, if current node dot data matches the required data, we are going to print data found, and we are going to return it so that we don't end up in a while infinite loop, and else we are going to update the current node dot next. Now we also want our find method to display data not found when the function fails to find our required data. So we can use an else clause along with our while statement. So this else clause will be run when our while loop terminates normally. Okay, I hope you know this concept in Python, and it's really cool concept to me. I really like this feature of Python. So we can write print data not found. Okay, I think this should work. Okay, so let's find any random data. Let's just my list dot find. Let's try to find 100. Okay, so you can see 100 not found. So let's find 0.5. It says 0.5 found. So I think this is working really good, and I hope you liked my version of doubly linked list, and I'm going to provide the source code below in the description. And thank you for watching, and do let me know your reviews about this code of mine. Thank you so much.